In an experiment aimed at studying the effect of advertising on eating behavior in children, a group of 500 children, 7 to 11 years old, were randomly assigned to two different groups. After randomization, each child was asked to watch a cartoon in a private room, containing a large bowl of goldfish crackers. The cartoon included 2 commercial breaks. The first group watched food commercials, mostly snacks, while the second group watched non-food commercials, games and entertainment products. Once the child finished watching the cartoon, the conductors of the experiment weighed the cracker bowls to measure how many grams of crackers the child ate. They found that the mean amount of crackers eaten by the children who watched food commercials is 10 grams greater than the mean amount of crackers eaten by the children who watched non-food commercials. So let's just think about what happens up to this point. So they took 500 children, and then they randomly assigned them to 2 different groups. So you have group 1 over here, and you have group 2. So let's say that this right over here is the first group. The first group watched food commercials. So this is group number 1. So they watched food commercials. We could call this the treatment group. We're trying to see what's the effect of watching food commercials. And then they tell us the second group watched non-food commercials. So this is the control group. So number 2, this is non-food commercials. So this is the control right over here. Once the child finished watching the cartoon, they weighed how much the meat, for each child, they weighed how much of the crackers they ate, and then they took the mean of it, and they found that the mean here, that the kids ate 10 grams greater on average than this group right over here. Which, just looking at that data, makes you believe that, okay, well, something maybe happened over here, that maybe the treatment from watching the food commercials made the students eat more of the goldfish crackers. But the question that you always have to ask yourself in a situation like this, well, isn't there some probability that this would have happened by chance? That even if you didn't make them watch the commercials, if these were just 2 random groups and you didn't make either group watch a commercial, you made them all watch the same commercials, there's some chance that the mean of one group could be dramatically different than the other one. It just happened to be, in this experiment, that the mean here, that it looks like the kids ate 10 grams more. So how do you figure out what's the probability that this could have happened, that the 10 grams greater in mean amount eaten here, that could have just happened by chance? Well, the way you do it is what they do right over here. Using a simulator, they re-randomized the results into 2 new groups and measured the difference between the means of the new groups. They repeated the simulation 150 times and plotted the differences given, the resulting differences as given below. So what they did is they said, okay, they had 500 kids, and each kid, they had 500 children. So number 1, 2, 3, all the way up to 500. All the way up to 500. And for each child, they measured how much, what's the weight of the crackers that they ate. So maybe child 1 ate 2 grams, and child 2 ate 4 grams, and child 3 ate, ate 12 grams, all the way to child number 500 ate, maybe they didn't eat anything at all, ate 0 grams. And we already know, and let's say, the first time around, 1 through 200 and 1 through, I guess we should, the first half was in the treatment group when we're just ranking them like this. And then the second, they were randomly assigned into these groups. And then the second half was in the control group. But what they're doing now is they're taking these same results and they're re-randomizing it. So now they're saying, okay, let's maybe put this person in group number 2, and this person in group number 2, and this person stays in group number 2, and this person stays in group number 1, and this person stays in group number 1. So now they're completely mixing up all of the results that they had. So it's completely random of whether the student had watched the food commercial or the non-food commercial. And then they're testing what's the mean of the new number 1 group and the new number 2 group. And then they're saying, well, what is the distribution of the differences in means? So they see when they did it this way, when they're essentially just completely randomly taking these results and putting them into 2 new buckets, you have a bunch of cases where you get no difference in the mean. So out of the 150 times that they repeated the simulation, doing this little exercise here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm having trouble counting this. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, I don't want to. It's so small. I'm aging, but it looks like there's about I don't know, high teens, about 20 times when there was actually no noticeable difference in the means of the groups when you just randomly allocate the results amongst the two groups. So when you look at this, if it was just if you just randomly put people into two groups, the probability or the situations where you get a 10 gram difference are actually very unlikely. So this is, let's see, is this the difference between the means of the new groups? So it's not clear whether this is group 1 minus group 2 or group 2 minus group 1. But in either case, the situations where you have a 10 gram difference in mean, it's only 2 out of the 150 times. So when you do it randomly, when you just randomly put these results into two groups, the probability of the means being this different, it only happens 2 out of the 150 times. There's 150 dots here. So that is on the order of 2%, or actually it's less than 2%. It's between 1 and 2%. And if you know that this is group, let's say that the situation we're talking about, let's say that this is group 1 minus group 2 in terms of how much was eaten, and so you're looking at this situation right over here, then that's only 1 out of 150 times. So it happened less frequently than 1 in 100 times. It happened only 1 in 150 times. So if you look at that, you say, well, the probability, if this was just random, the probability of getting the results that you got is less than 1%. So to me, and then to most statisticians, that tells us that our experiment was significant, that the probability of getting the results that you got, so the children who watch food commercials being 10 grams greater than the mean amount of crackers eaten by the children who watch non-food commercials. If you just randomly put 500 kids into two different buckets based on the simulation results, it looks like if you run the simulation 150 times, that only happened 1 out of the 150 times. So it seems like it's very unlikely that this was purely due to chance. If this was just a chance event, this would only happen roughly 1 in 150 times. But the fact that this happened in your experiment makes you feel pretty confident that your experiment is significant. In most studies, in most experiments, the threshold that they think about is the probability of something is statistically significant if the probability of that happening by chance is less than 5%. So this is less than 1%. So I would definitely say that the experiment is significant.